Okay, guys, let's see. Oh, I didn't take it. So, all right, this is the law of sines. Okay, so far in the class, we've been working with right triangles. In this section, we're not working with right triangles, but we have the law of sines that will help us solve triangles that are not right triangles. So here's a definition. An oblique triangle does not contain a right angle. We can use, so an oblique does not contain a right angle. So a squared plus b squared is not equal to c squared. You can't do that. You can't use the Pythagorean theorem. So you use instead the law of sines. It says side A is proportional to the sine of angle A is proportional to side B, the length of side B, which is over sine of angle B equals C over sine of C. And if I draw a picture, this is a triangle. I'm trying to make it not look like it's right. It's hard for me to draw a triangle that's not right. That looks like a right angle. It's not, okay?
That's supposed to be.
It's not a right angle. A, B. I don't know why it's hard for me to draw a triangle. So, the length of side, this is side A across from angle A. This is side B across from angle B. And small c, that's a small c, this is a capital C. So that's the angles are capital letters, we've done this before, and the length of the sides are small letters. So the law of sines can be used to solve a triangle. What do we mean by solving a triangle? It means we're
Finding the sides.
right, finding all the angles and all the sides. Yes. So that's when we did that before, we solved a triangle in another section, but it was a right triangle. So we can use the law of sines to solve a triangle with the following known measures. If we know a side and an angle, and angle, side, angle. That means, like, if we know angle, side, angle, we can find the rest of them with the law of sines. If we know a side, angle, angle, we can use the law of sines. Okay, and then, so we're going to do some examples. Solve the triangle. This is not a right triangle, so we draw the picture. It's saying that this is side C, A. This is 82 degrees. A is 64 degrees. And side C is 14 centimeters. And we're going to round to the nearest 10. So, all right. So we have a side angle here. So we can use the law of sines. So what do the angles add up to in a triangle?
180.
So we can find angle B. Angle B is going to be 180 minus the sum of the other two angles. And that equals 34 degrees. Okay? Now, we're missing side A and B, and so we can find, we know a side and an angle here, so we know small c over sine of angle c. So we're gonna, that is 14 over sine of 82 degrees. And that is going to be equal to A over sine of, so it's going to be equal to A, which is unknown, over sine of angle A of 64 degrees. So if you could cross multiply, or you can multiply through by sine of 64. You want to get sine of 64 degrees. So our A is going to be 14 times sine of 64 degrees divided by sine of 82 degrees. So, of course, this cancels. Okay? So we're going to put that in the calculator. And what mode does the calculator have to be in? Degrees. Mode. It's in radians, so we've got to change that. And it should be in function to, the other day I turned it on, it was in polar mode or something here. But yours won't have that problem. Okay. Second width. Okay, so this is 14 times sine of 64. And I have to close the parentheses or it still thinks I'm in sine, divided by sine of 82. And it said rounded 1 decimal place. So it's approximately 12.7 and it's in centimeters. That's what A is. All right, what's B?
Put 12.71 over 64 and so
4 degrees. Equals our C over sine C, which is 14 over sine of 82.
And so B is going to be sine of 34. It's probably just easier to multiply through by sine of 34. Okay, so this material right here is actually a little easier than what we just did, so you probably do want to test on this. You really probably really do want to test on it. Does it seem a little easier? Yeah, I think so. Okay? It does seem easier, doesn't it?
This is just the first section, so.
Yeah, this is, I believe this section is a little easier. Sine, you've covered the hard stuff in this class now. Okay. So, how much harder do you think this class is than Math 1710?
there's a learning curve and there's a few really tough units.
Yeah, yeah. Sometimes I tell people it's like 10 times harder. 5 times, I don't know.
I don't like the math lab in this one as much.
Oh.
Because there are practice tests. I don't like that. Those helped me a lot in 1710.
Oh, MATLAB went more with my test? Or?
The practice tests were great because it kind of, they weren't exactly the test, but it was the same idea behind what you were doing. So you get a feel for it before you actually took the test.
Yeah. So we have solved the triangle. Okay. Here's an example of an angle, side angle. Okay. I didn't turn the page yet. Okay, and I'm just going to try to draw this again. And I don't really know how helpful those Nearpods are. They show pictures, but I'm drawing pictures. So, let me know if you want me to display those. B, A, C, small a, small b, small c. Okay, so this is 40 degrees. This is 22.5. B is 12, and it didn't tell you the unit, so we'll leave you to talk. All right. We did remember. Yeah, I remembered to go ahead and put the units and the degree symbol on the last one. So, okay, so we can find angle B. It's just going to be 180 minus the sum of the other two angles. And if you do that in your calculator, did I write this? Yeah, I did. It's 117.5 degrees. Okay, so that's one answer. And then we do the rest just like before. So this is 117.5 degrees. Okay. Now, so in order to use the law of sines, you have to be able to get so that you have something b over a known value over a sine of a known angle. So now we know b over sine b. And it wasn't a problem that we didn't know that when we started because we could easily find that third angle. So we're going to use proportions again. Now we just need to find sides A and C. So it's going to work exactly like we did the other one. So that is going to be 12 over sine of 117.5. And that's going to be equal to C over sine of 22.5. So then we're going to multiply by sine of 22.5. So C is this. We'll put that in our calculator in a minute. And then A over sine of 40 degrees is going to be equal to the 12 over sine of 117.5 degrees. So we're multiplying through by sine of 40 on both sides. And that's what A is going to be. So we'll just put those in our calculator. Okay. Clear it out. So we have 12 times sine of 22.5 close the parentheses. If you don't close the parentheses, you get the wrong answer. You'll think you're still in a sine. Divided by sine of 117.5, about 5.2. Did you get that?
Yep.
Okay, and the other one, it's going to be the same. I can recall my last entry, and I'm just going to replace 22.5 with 40. 40, and then hit delete. This is a word processing here. Okay, so now I got this one written in. 8.7. And we have solved the right, it's on the right track. Solve the oblique triangle.
Just doesn't have the same ring to it.
It's, yeah, I know, we like right triangles, don't we? Anyway. So remember, don't use a squared plus b squared equals c squared. Good. Okay, and you can also, on this law of sines, if it's convenient for you, it's convenient, you could flip everything. You can have sine of capital A over A. It could be flipped. So you can flip it. And it's more convenient to have the unknown in the numerator. So if the unknown is going to be an angle, then you're going to want to flip it. But on the examples we just did, we don't want to flip it. Okay. All right. And then what happens, though, when we're given two sides at an angle opposite of one of them? Side angle. Here's what happens there. Okay. And there's good pictures in the book on this. When we're given two sides at an angle opposite of one of them, side angle, there may be one, two, or no triangles that fit the measurement. This is called the ambiguous case. Now, maybe the slideshow would be good now, so I'll bring it up. We're going to do some examples of that in a minute, but let me just go ahead and get this. I will go ahead. I'm thinking that earpods is there. Oh, I'm not going to remember. Oh, wait, let me go ahead. Okay. All right. 1720. And chapter. Oh, no, sorry, I forgot it. I don't seem to have that. So there are PowerPoints in Shobi. I guess I have to stop making that. Or I could show you the book, but. Okay, so (6.1) PowerPoint. So here's a nice picture. It's right out of the book. The ambiguous case. So if you've got two sides and then an angle given, the angle's not between the two sides. This is the ambiguous case. You could have one triangle, and here's a picture. when A is greater than the height and A is greater than B, one triangle is formed. Or you can get one right triangle when A equals H. It's just the right length to form a right triangle. But if A is less than H and is not long enough to form a triangle, you get no triangle. And you can get two triangles in this case. If A is greater than H, but less than B, two distinct triangles are formed. So, and you're going to be able to tell, if you take the inverse sine of something and you get an angle that won't work, you'll know it's. Let's show some examples then.
Should we write that down? Or
Oh, it's in the book. This is a slideshow posted on Shobi, so you might want to take a note. I just thought the pictures might help you understand it. So we're going to do this example now. Okay, so all right, so we're going to solve when, let's draw the picture. The picture isn't necessarily great. Let's see, this is 10, this is angle A, they said it's 50. I made A over here this time. B, C, small b. Okay, so we got an angle. So we know A over sine A. That's known. We have to have one proportion to use the law of sine. So that's going to be 10 over sine of 50 degrees. Oh, and they told me B is 20. Okay? So, I should have easier. B is 20,
And we don't know sine, we don't know angle B.
so we could solve this either by cross multiplying, or we could have flipped the whole thing. If I rewrite it up here, sine of B over 20 equals sine of 50 degrees over 10. And then we can multiply through to solve for sine B. We multiply by 20. So we're going to get sine of B. Let's see. So we're going to do sine of 50. Sine of 50 times 20 divided by 10. Well, that's actually just touch. Oh, what did I do?
Put it all inside sine.
Yeah, it's all inside the sine. No.
Close the bracket.
Second insert. I told you got to close the parentheses. I wouldn't have gotten the right answer. Okay, and so we get sine of B equals 1.5321. Now, here's the sine function. And it goes from 1 to -1. So can we have of angle B that has a sine that's over 1? No. So, or you could try sine inverse. If you don't remember that, it's going to give you an error. So, this is impossible. So, there's no solution. So you're going to write that there's no solution. And if I had drawn it more to scale, maybe you could have seen that there was no solution, but from the picture. But you got to show something like this, and then circle, put no solution. Okay? So that's where there's no triangle. So it was obvious there was no triangle because we got a sine more than 1. A sine more than 1. All right. Okay, the next example. This example has 2 triangles. So I'm going to draw them both. I've got them on the filled-in notes. One sort of looks like this, and the other looks like that. If I let this be A, this be B2, C2, A, B1, C1, and I'm given that B equals 16, A equals 12. There's these capitals. A is 12. B is 16. And then we have a C1. Oh, I wrote that in the wrong place. A is a little side A is the opposite. This is C2, small side C1. Okay, so we solve one at a time. The known ratio, we have to have a known ratio to use law of sine. And, okay, and we're going to be looking for an angle here, so the known ratio is sine, I'm going to write it as sine A over A. That's going to equal sine of 43, no, A is 35. What, I'm looking at the wrong one. Sorry? Oh, I should label A. A is 35 degrees. Sine of 35 degrees and divided by 12. That's our known ratio. And we have a known side of B, so we can find angle B next. Angle B1 next. That's going to be sine of B1 divided by 16. Now, forgot what color I was using. All right. We're going to do times 16 times 16. And I think it's a little easier to flip it if you're looking for, I'm going to be looking for angles in these when I don't have 2 angles. Okay? But you can do it either way. I did on the filled-in notes. I cross-multiplied, and you can find it. You can manipulate it, but okay, so we get sine of B1 equals all that. So we're going to put that in our calculator.
0.7648.
Yeah. Do you guys need to see me put it in the calculator? Yeah, you get 0.7648. If you put that in the calculator, 16 times sine of 35 divided by 12, you get that. So now you can, that is a number that's less than 1, so it does work. So B1 will be the inverse sine of 0.7648. And we're going to round the angles to degrees, and sometimes, you know, you can just use all the digits. If you did 16 times sine of 35, close the parentheses, divide by 12. And now you can do sine inverse, second sine inverse, or inverse sine of second answer.
You're gonna change your radians to radians, right? Or you stay?
No, this is degrees. We're doing, these are all, we're gonna stick, we don't need to change this to radians. That's you're getting confused because this looks like radians here. This is a sine of something. It's the sine of something. It's everything's in degrees. We're keeping this in degrees this time. And to the nearest degree, that would be approximately 50 degrees. So B1 is approximately 50. Okay, so we've got 50 degrees over here. Now we can find C1. I'll write it here. C1 is going to be 180 minus 50 plus 35 is 95. Yeah. All right, and now we can find the missing side, C1. So C1 over sine of angle C, 95 degrees, is going to equal to the sine of A over A. I may as well use what I was given at first in case I made a mistake somewhere, although it would carry through over here. But if you can and you're choosing things, you may as well pick things that were given to you first. Sine of 35 over 12 multiplied through by sine of 95 and that's going to be our C1. Sine of 35 times sine of 95 divided by 12. And I closed all my parentheses, right? Yes. Okay. And, did I do that right?
Isn't it 12 times sine 95 divided by sine 35? Or is that the same thing? Because I got 20.8.
Oh, let me look at mine. Yes, you're supposed to get 20.8. Did I do? Oh, I split this. Bad me. Okay. This was flipped. We got to keep. This is 12 over sine, and I knew I did something wrong because I got a totally weird answer. There's no way you're going to have a side. I'm gonna have to say 0 to the nearest 0.1. Okay, so I have to keep the ratio the same. I had side over sine. This has to be side over sine. Sorry about that. So, you do get, if you put that in the calculator right, it is 12 times sine of 95, close the parentheses, divided by sine of 35, 20.8. So that's one of them. Okay. Let's look at, remember when we took inverse sine and we got 50 degrees? For these triangles, the sum of the triangles add up to 180. So you can't go beyond 180, but we got 50 degrees for one answer. About here would be 50 degrees. What other angle here would have the same sine? It's in quadrant 2.
130 degrees.
This is the reference angle is 50, but it's 130. It's 180 minus 50. So B2 is going to be 180 minus 50 degrees. Or if you draw the picture, you can see it's 130. So there's a second angle. Whenever there's two angles that would have that same sign, you have to find the second one. So there's a second triangle. That's how we know there's a second triangle. So this is building on what you've already learned. So B2 is 130, and now that we know B2, 30, and A is 35. Now we need to find C2. C2 is going to be 180 minus 130 plus 35. Is that 15 degrees?
25.
It's what? 25?
Is that right?
65?
Oh yeah, you're right.
It's 15. Okay. So angle C2 is 15 degrees. And do put your little degree signs on them. That'll help me differentiate if you're talking about an angle or if you're talking about the side. Okay? And then, what are we missing? Just side C2. We have to find side C2. So we make a ratio. Side C2 is to sine of C2, 15 degrees, as the known ratio, but we need to put 12 first over sine of 35. So whatever you want to do, if you don't want to flip these things around, you don't have to. Sine is 15 times sine of 15. So that's what C2 is. 12 times sine of 15, close the parentheses, divided by sine of 35. Okay? And we get 5.4. Side C2 is approximately 5.4. So we've got two right triangles. Right? Example C, this is one triangle. And you're going to see why it's one triangle when we find the sine of something. There won't be two answers. That's how you know if you get an impossible sine of an impossible number, no solution. Sine of a number that you can have more than one solution, that would be 2 triangles. And sine of a number where you can only get one answer, it's going to be just 1. So, and I'll show you that. So here we've got, I drew the picture. B, small c, capital C, small a, big A, small a, small b. Okay, so small b is 62, small a is 81, a is 43 degrees. So our known ratio, we always have a known ratio on these. And we're going to be looking for, anytime we're given 2 sides at an angle, we've got to find another angle first. So I'm going to write it as sine of A over A. All right, I'll just do it this way. Sine of 43 divided by 81 equals, all right, we have to use the one where we know the length. So sine of B divided by 62. We're going to solve for sine of B, so we're going to multiply by 62. So sine of B is all of that. Let's find out what it is. It should be 62. 62. Hey, I could, times sine of 43, close the parentheses, and then divide by 81. So sine of B is approximately 0.5220, but I can use the whole number and take sine B is sine inverse of 0.5220. And I'm just going to keep all those places by doing second sine inverse, second answer. And I get 31. They said to round to the nearest degree. And so we're just going to use 31 degrees, approximately. Okay? All right, so draw the picture. Well, no. Okay. If I don't draw the picture, sine is positive in quadrants 1 and 2. So, I mean, you can draw this picture again. We have 31. This is 31. So this is 180. So this would be B1. B2, if it exists, would be 180 minus 31 is 149 degrees. Well, that's impossible because A plus B2 43 degrees plus 149 is 192. That's, I don't know if you can see that. That's 192 degrees is greater than 180. The sum of the interior angles of the triangle equals 180. It can't be greater. So this is impossible. So there's not a second triangle. That's what I'm showing you here. There's not a second triangle. But there is a first triangle, so we don't even have to call it B1, but with B equals 31 degrees. So, okay, so B is 31 degrees, and there's only one triangle. We can find C by taking 180 minus 43 plus 31, and that is 106. Now we got 106. Now all we need is side C, so we take C over sine of 106 equals our known ratio, 81, I split it, over sine of 43. So that multiply through by sine of 106. $81 times sine of 106, close the parentheses, divided by sine of 43. That's 114.2. That's side C. It's not an angle. Don't put a degree sign on it. But yeah, that's what I got. That's side C. Okay. I get the. Okay. Any questions? And so it did get more complicated. But does it kind of make sense why there'd be 1, 2, no triangles? Sort of. Okay. Okay. Well, and the book is really good. I do recommend you read the book. Okay, so the last thing for this section. Got one more page. So if you need to find the area of an oblique triangle, it's given by 1/2 side B times side C times the sine of the angle between them. So this is B. This is A down here, so that's small a, this is small c. So 1/2 times side B times C times the sine of the angle in between them. So it can be written as 1/2 A times B times sine of C, or it's 1/2 A times C sine of B. So this is just the angle between them. That's just the angle between the known sides. So find the area of this triangle. So we're going to use the sides we know here and take the sine of the angle in between them. So it's 1/2 8 times 8 times 12 times sine of 135 degrees. The area, capital A. Oh, I should write area. The capital A looks like it's the area is that, and you put that in the calculator. You get 4 times 12 times sine of 135. And it didn't, I just rounded to 34. But,
Could you do 48 times the sine of 135? Just simplified even more.
oh, sure.
Okay.
Yeah. 34. And it's in meters, so the area will be meters squared. So that's very simple to find the area. All right. And then here's a word problem. We have 2 fire lookout stations. They're 13 miles apart. Okay. With Station B directly east of Station A. Both stations spot a fire. Oh, have you ever seen, anybody hiked I'm trying to remember, not the, I can't remember what it's called. And just north of Abingdon, there's these rock formations. Now I can't remember what it is.
Creeper Trail?
No. It's very famous, but actually probably not a lot of people know about it. It's off of the Meadowview exit, and you have to go up into the mountain
Maybe
and hike.
Appalachian Trail?
It's what?
Appalachian Trail?
No,
No?
it's a Brumley Mountain Trail.
Oh, nice.
Brumley Mountain Trail, and there's a place to park, and it's a 3-mile hike uphill, and then I don't know why I can't remember the name. I keep thinking it starts with a C. Column, Cascade, no. Anyway, I'll remember it and let you know next time. But there's a fire station up there. That's what reminded me of it. There's an old, if they don't use it anymore, it's falling apart and stuff. But they used to have rangers in these fire stations, spot fires. Okay, but anyway, here's the bearing of the fire from Station A is 35 north. So this is the north line. 35 to the east. So this angle is 35. And then the bearing from the fire station from Station B is north. So this is again north, and it's 49 degrees toward the west. So that's 49. This is the side. This is 13 miles. How far to the nearest tenth of a mile is the fire? Here's the fire from Station B. Okay, so okay. There's our fire. Okay, so we can find this angle. This is going to be, we're going to call this angle A. It's here. That's going to be 90 minus 35. 65, right?
55.
55, right, okay. A is 90 minus 35 degrees is 55. And we'll call this B here, and B is 90 minus 49, and that's 41 degrees. Okay, so we know 2 angles and a side in between them. So we know angle, side, angle. So we can use, oh, I finished it. Okay. So we can use this law of sines. What's our known ratio?
You're going to have A over sine 55.
Okay. 13 degrees is C. Oh, we're gonna find C first.
It gives.
We have to find
Oh,
this.
right. I see.
We have to find C is 180 minus those two angles added together. Because we didn't have a known ratio yet. We have only one side. So these rangers would take their law of sines and they would be. So when you subtract that,
84.
it's 84. Yeah, 84. And so now we're going to use the law of sines. Our known ratio is, and we want to find this side, A. How far is fire from station B? That's this length. Okay, so our known ratio, and we want to write it as is small c over sine of C, which is 13 over sine of 84, is A over sine of 55 degrees. Multiply, we're going to find A by multiplying through by sine of 55. So we put that in the calculator. 13 times sine of 55 divided by sine of 84. 10.7. Did it say to the nearest 10? Yep. So side C is 10.7 miles.
On a test, let's just say we set the two equal. Do we have to show that we're canceling out the sign, or could we just use the law of proportions or whatever and just plug it in the calculator? Does that make sense?
Oh, you're just asking if you have to show
Yeah.
that. Probably you have to show the ratios,
Right.
and I think if you'd have the ratios, that'd be all right.
Okay.
If you start skipping too many steps, you're likely to make a stupid error, though. Like, a mistake. So that's. I mean, I want to see work, but okay. And I don't know. We have 10 minutes left, but I think on a schedule, do I have? I was supposed to cover. No, I don't have. What I was supposed to cover. But 6.2 is more the same. I don't have a whole day for a test review this time. So let's just go ahead, and I know you guys would like to leave, but let's start the law of cosines then. So we can get ahead and maybe have a whole day for review. So the law of cosines this is, and I do recommend you read the book. The law of cosines is used when two sides and the included angle is known. So side, angle, side, or when three sides are known, side, side, side. So the law of cosines is a squared equals b squared plus c squared minus 2bc cosine of A. Okay? So, or you can write it, so whichever side this is the unknown side. This is going to be the angle. That's why we use angle A. So this can be rewritten. And you guys, when you come in late, you have to let me know when you come in, I think. Or you just be marked out for the whole thing. She was here. Who else came in later? Did they already leave? Tina did. Oh well, if I don't get it, did somebody else come in later? No, okay. So it's b squared. So it depends what you're looking for. If you're looking for side A, you want to set it up this way. It can be also written this way. So it's cosine of capital B because we have b squared on the left here. Or it can be written as c squared equals a squared plus b squared minus 2ab cosine c. So here's the step to solve a side angle side triangle. Use the law of cosines to find the side opposite the given angle. Okay, use the law of sines to find the angle opposite the shorter of the two given sides. And find your third angle by subtracting the two angles from 180. I'm just going to write subtracting from 180. You know what I mean? You're going to add up the two angles you know and subtract from 180. And I filled in notes, have it all written down. So, alright, we'll just stop there and I'll do the example next time. And then we'll start 6-3 next time too.